Hi guys! In this video we are going to go over our first non-rigid transformation. So we're looking at k times f of x. So you take your original function, which is going to be shown right here. So this is the original function we're working with for this one. And what this happens to show is a cubic function. But all I'm going to focus on are the 3 points that are noted. So I have -1, -1, 0, 0, and 1, 1. So now I'm going to use this function to show different features of what happens when you multiply that function by a value. So if you say y equals 3 times f of x, this is what happens. So this function, I have the points -1, -3, 0, 0, and 1, 3. Now just take a second to look at the differences between this table and this table. What you're probably recognizing is that the x values stay exactly the same and the y values changed. Now the function says 3 times f of x. If I take the y values and multiply them by 3, I get these values. So my instinct here is that when I multiply a function by a constant like 3, I multiply the y values by that constant. Let's see if the next two sketches hold true to that. So in this next one, I have the function 1/3 f of x. Now what I see is -1, comma, -0.0333, which I'm going to write as a fraction. That's actually equal to -1/3. And then I have the 0.00. And then I have the 0.1, comma, 0.333, which is 1/3. Now again, let's notice the x values stayed the same and the y values were multiplied by this coefficient. So now if I were to make a sketch of 2 times f of x, my instinct is that my x values are going to stay the same. And my y values from the original f of x function will be multiplied by 2. So this would be -2, 0, and 2. So I'm going to sketch those points. -1, -2, 0, 0, and 1, 2. So this is what it would look like. So as you can see, when you multiply a function by a coefficient or constant, what happens is you have what's called a vertical dilation. Now, what you might remember is this word dilation is coming from geometry, actually. When you zoom in and out of something, you're dilating it. If you think about your pupils being dilated, they get bigger and smaller. If you think about zooming into a picture, I always use that one. When you zoom in, you're dilating that picture. It's just making everything bigger or smaller. So if you have the value of k, the absolute value, because in this situation, the plus or minus doesn't matter. We're just looking at that value. When you have the value of k is greater than 1, when you multiply k by f of x, so that's looking at 3 times f of x in the top right and 2 times f of x, it represents a vertical stretch. In this situation, the y value gets multiplied for the same x values. Actually, multiplied by k. So this is a little tricky, but the graph is further from the x-axis than f of x. So what that means, yes, this value stayed the same, but these values went from 1, 1 and negative 1, 1, and they moved out further. When you have the value of k between 0 and 1, so that's here, when you had 1/3 f of x, this represents a vertical shrink. The y value gets multiplied by k for the same x values. So both times you're getting multiplied by k. It just depends on if it's going to get bigger or smaller. And if it's getting bigger, you have a larger k value. Smaller, you have a smaller k value. And in this situation, notice this one, it's stretched away from the x-axis. This one, it's shrinking, so it's getting closer to the x-axis. So there's one last thing I want to show you in here. I'm going to take a picture of cute puppies. I always do this because I think it's kind of fun. So let's see. Oh, this is my favorite one. So if I take this picture, copy image, and I go to our document. Now this is going to be sort of make this a little bit similar to you or more familiar. There we go. There's my cute puppies. Now, if I take these puppies and I do a vertical stretch on them, this is not working out. There we go. I do a vertical stretch. Notice they did not get wider, they just got taller. If I take these puppies and do a vertical shrink on them, they get shorter. They're not changing width or anything. They look wider, but they're staying the same width, just getting shorter. So when you think about this vertical stretch and shrink, think these x values are staying the same. It's the y values that are stretching out.